We have this linked list and we're supposed to detect cycles in this linked list. So over here, you see there's going to be an arrow that comes back from 4. When we read this linked list, it's going to be 1, 2, 3, 4, back to 2, and then 3, 4, and then back to 2. And it keeps going on. And this right here is called a cycle, and we need to detect that using code. Welcome back, everybody. We're going to be doing a LeetCode problem called linked list cycle. And it says given the head, so this is going to be a head of a linked list, the head of the linked list. Determine if the linked list has a cycle in it. So if we're given this head, we need to determine if the next values after this head is going to have a cycle. So it says there is a cycle in the linked list if there is some node in the linked list that can be reached again by continuously following the next pointer. These arrows right here are the next pointer, and if we keep following this head node's pointer, it's going to go to 2, 3, and then 4, and then right here you see the cycle and it goes back to 2. Internally, pause is used to denote the index of the node that tail's next pointer is connected to. Note that pause is not passed as a parameter. If we have a cycle in this list, we're given a head and the position that the cycle occurs at. If our pause equals 2, then that means our cycle is at 2. But we're not being given this pose position, just that over here in the input it says pause equal 1. This is 1's position in the linked list because we start from 0. Anyways, we're just given a head for the cycle. So for this linked list, we're going to return true because this has a cycle, and for this linked list, we're going to return false because it has no cycle. So my initial thought to how we would solve this is we make a set, right? And within the set, we just go through this linked list by doing our current value dot next. So when we do cur equals cur dot next, so let's say this is our current pointer. That means we're going to go to the next pointer and then move our current pointer over here. So then we just keep looping through this pointer until we reach this 4. Then what's going to happen over here is that we're going to have the values 1, 2, 3, and 4. So then when we loop back around over here and it goes back to 2, we're going to see that we have this node. And since it's already in this set, we're going to return true because there is a cycle in this linked list. So yeah, that was my first thought when solving this problem because, if you see a duplicate and we don't want any duplicate values, then we use a set. So currently our code is going to look like this. We're going to initialize a set. And now what we are going to check is that if this current is equal to nil, then that means we are going to return false because if we don't have this pointer anymore and this 4 leads to this nil value, then we're going to say, wow, we don't have a cycle in the list. So that's why we would put, well, there is a current value that we're at. And to make this current pointer go forward, we're just going to do cur equal cur dot next. And then inside of here, what we're going to do is we're going to check if our current value is in the set. Then we would return true. And then after we go through all the values, if we haven't returned true, that means we went through all the values. We hit this nil part, and then we would just return false over here. This is actually running in O of n time, but our memory, since we have a set, we're going to put all these numbers into this set value. Our memory is actually going to be O of n time as well. So this is both linear time because we're going through each value one by one for time and space. So now we're just going to code that in Python. Over here, if we want to use this function as a recursive value to call itself, we're going to have to define our set outside of this function. So we're just going to make a scene set. Our values that we have seen is going to be in this set. So then we need to check now if our head equals null, because if we have no value in here, then we are going to return false because there is no cycle in the linked list. So this is the first line. Now our second line is if we do have the head in the scene set, then we would return true. That means we found the cycle in the set. Now all we need to do is we need to recurse our function, so we go to the next pointer and we just keep going through this set. But what we also need to do is that we need to put the value of head into our scene set if we haven't seen this value. Sorry, I forgot to add this because I just remembered it. How are we going to check if the head is in the scene set if there is no value, if we're not adding a value at all, right? Recursion's kind of tricky, but basically we're going to have a recursion function, right, of our head over here. So if we do recursion at 3, we're going to check if the head is, if there's not a head, then we wouldn't do this. So we're going to the next if statement. So then if the head isn't seen, which right now if we put rec at 3, so rec at 3, we are not in this scene set, so we're just going to put 3 here with this else statement. Then when we do return has cycle, it's going to do rec 2, and then we're going to put 2 here, and then over here we're going to put 0, rec 0, and then we're going to put 0 here, and then rec -4, and then we're going to put -4 in this set. Sorry, I don't have space. Once we go back to 2 again, so once we do rec at 2 again, this value right here, it's going to return us true because the head is now in the scene. So this 2 is now in the scene value. So over here, we're going to return true. And since this is true, what it's going to do at rec number 4 is we're going to return has cycle at 2, and this is going to return true. This is going to return true. This is going to return true, and this is going to return true. That's just part of recursion, guys. So yeah, it should work. Oh, sorry guys, I have to I have to put self because we're using the scene, but it's outside this function. Oh, sorry. We're going to have to add the head. My bad. And this is going to have to be self again because we're calling this function. Okay, since we're calling self over here, we don't need to pass in this self because it's calling itself. It's just something weird with Python. It's like Lua when you use a self keyword. So this is the whole code for Python. And you guys will see that it works. So now let's code this in Lua. So a prerequisite for you guys is that we need this linked list module, and I'll post the video about linked lists inside the description. It'll also pop up on your top right of the screen. But basically we're going to have a test case with this linked list, and then we're going to put these nodes in here. And how we wrap around the test case, this 4 back to the 2, is we're going to do something interesting here. We're just going to do test case dot root dot next dot next dot next equal root equal test case root dot next. Root dot next dot next dot next is going to be root dot next dot next dot next is going to be equal to root and the next value. This is our linked list setup right here, and we're going to have a cycle. I don't want to I don't want to print this out because in a cycle it's just gonna crash this Roblox studio. And what we'll do is we will just write the function detect cycle or something, and we will give it a root, or we are given the head. And then I want to print out this text cycle with test case, and we give it the root of our linked list. So this is going to detect our cycle. Let's just say has cycle, and I guess we need to define our set, right? So we have our set outside this function right here, and our set is going to actually be called scene for your guys' readability. And then what we're going to do is we're going to use recursion from this right here, is that if there is a current in the scene set, if our head, which is we're going to call it current, if our current value is in the scene set, so if current in scene, actually you're going to say scene in current. So what I'm going to do here is I'm going to use a table in Roblox, and it's going to be key value pairs, and then it's going to be, you guys will see what happens, but this is going to have a value of the current node, which is 3. So this is going to be 3, and then we're going to have true here. So we're going to put this inside our scene set. So then when we put the 3, which our current node is at, in this scene set, we're going to return true. If we have it, then we're going to say return true, because we're going to make this function call. I have no idea what I said. I forgot the terminology, but we're going to make this recurse. There you go. Else what we are going to do is we are going to do scene and current equals true. So this is adding into our scene set. Honestly, we need to check if this is also equal to nil. So if current equal nil, then we would also return false, because that means that there is no cycle. So we're gonna do one with a cycle and without a cycle, so you guys can see that it's, or all of this is correct. But anyways, then we would return has cycle at current.next. Okay, so this is our base case, is that if there is no cycle, or if our root is nothing, then we would be like, there's nothing in this linked list. But this should all work out fine. So we're gonna have a test case 2. I'm just too lazy to put 1 here. So we're gonna have test case 2 where there is no cycle. So this one is not gonna have a cycle. Test case 2 is not gonna have a cycle. So we're just gonna check this now. So false and true. That works well, guys. Let's use test case 3, which we have no values in here. I'm pretty sure it's going to return false. So let's just do it in order, 1, 2, and then 3. And over here, you guys see true, false, false. So that was my solution, guys. There is a O1 memory solution, which is using 2 pointers, but this video is getting kind of long, so I'll see you guys in the next video. I'll make the 2 pointer solution if you guys like this video and subscribe, but I'll need like 50 likes, boys and girls. But yeah, see you guys. Take care. Bye.